In this video, we're discussing the asynchronous version of the electron motion in a magnetic field lab. For this lab, we have filmed a cathode ray traveling through an evacuated chamber inside of a Helmholtz coil, which produces a uniform magnetic field. In the videos, you will see what happens when an additional magnetic field is added, and when we change the strength of the magnetic field and the velocity of the charges in the cathode ray as they're moving through the device. During the exercise, you will be determining the charge to mass ratio of the electrons. If we think about electron motion in terms of purely mechanical motion, we will have objects moving in an orbit, and we can figure out their speed, and we can figure out the centripetal force. The missing component would be their mass. If we think about this in terms of purely electromagnetism forces, we have a moving charge in a magnetic field, and we can figure out that path again, where the missing object would be what is the charge of the electron. We don't know the charge and we don't know the mass purely from these measurements, but by combining those two approaches, we can get the ratio of the charge to mass of the electron, and that is what you're going to be finding. To do that math, we need to know the velocity of the electron, which will be proportional to the accelerating voltage. We need to know the strength of the magnetic field, which will be proportional to the current being sent to the Helmholtz coil. And we need to know the radius of the path, which will be measured using a glass ruler inside the device. You will then take that data and graph it to get the charge to mass ratio of the electron. You may have noticed that's 3 variables on 2 axes. So you will need to redefine those axes so that you can put 3 variables on. And you'll do that by defining a new axis that contains 2 of those variables. Now, math is true, so there are lots of combinations of what variables and what coefficients you could put in different places. Do you want that coefficient to be on the y-axis, on the x-axis, on the slope of the measurement? There are lots of ways to do this that are all true and correct, but some of them might be a lot easier and clearer than others. So you're going to need to think about how you define your axes in terms of ease of use of the resulting graph. Thank you for staying to the end of the video. Here's this lab's fun fact. There is no animal today that eats the avocado the way that is most advantageous for that plant. It's really optimized for a large herbivore megafauna, like the extinct giant ground sloth, or a mammoth. The only reason they're today you have them for your guacamole is because humans have been cultivating them.